process.
Hello,
How are you?
I'm good. And you?
How are you?
I'm good. And you?
I'm doing well. Did you solve that problem?
No.
Okay.
No.
Okay. Do you have that problem? Can you
Yeah.
just write down the problem and get started? Okay, our problem is 2x minus y plus 1 dx plus 2y negative x plus 1 dy equals 0, right? So
Yeah.
we have to use the method to simplify this differential equation. And the topic that we are doing, it's kind of reducible to homogeneous differential equation, right? So we can
I don't
write
know if
this.
it's the same problem because you write it.
Oh, yeah, it's the same thing. It's the same thing. So we can just simplify. If the problem will be in this format, you would write it as dy by dx, you would simplify, equals 2x minus y plus 1 over x minus 2y negative 1 after simplifying, right?
Okay.
You can simplify this in this format. Now, what's the first step? Basically, you have to follow a couple of steps to solve this problem. First step, you have to replace the small x with capital X plus h. This is substitution. And small y is equal to capital Y plus k. Plug in these substitutions in the given differential equation. And one more thing, we have to convert small dy by dx into capital dy by dx because we're going to introduce a new variable, capital X and capital Y. Therefore, we would have to find the derivative dy by dx in terms of capital X and capital Y. So if you would take the derivative on both sides with respect to capital X, so it's going to be dx over dx with respect to capital X. The derivative of capital X would be 1, right? And the derivative of h and k are constant, so it will be 0. And capital small dy by capital dy is going to be 1, right? Now, if you would multiply dx, capital Dx on both sides, it's going to be dx equals capital Dx. And dy, small dy is going to be capital dy, right? Now, if you would divide both equations, left with left, and right with right and left with left, so it's going to be capital dy over capital Dx. It's going to be dy by dx. It means small dy by dx is equal to capital dy by dx. So we can replace this dy by dx with this one. Got it?
Yeah.
So this is our substitution. This one, we're going to plug in this one and these two equations. So it's going to be capital dy by dx equals, it's going to be 2 times capital X plus h minus y is capital Y. There is negative y, so it's going to be this y plus k will turn into negative y negative k plus 1. You got it? Over
Yes.
Small x is capital X plus h and minus 2 times capital Y plus k minus 1. Okay, what's the next step? We have to simplify the top and bottom. Multiply 2 inside the parentheses, 2x plus 2h minus y minus k plus 1 over x plus h minus 2y minus 2k minus 1. Okay, so it's going to be dy by dx equals, we have to combine x values and we have to isolate the constant terms like h, k, and 1. So you will write 2x minus y and plus 2h minus k plus 1, right? Over. You have to combine these values, x minus 2y, x minus 2y plus h minus 2k minus 1. You got it?
Yeah.
Perfect, perfect. Now, what's the next step? Did you remember that?
Yeah, you have to write 2h minus k plus 1 equals 0 and h minus 2k minus 1 equals 0 and solve the system.
Exactly. So we have to take the constant terms equal to 0 to reduce the given differential equation into homogeneous. So it's going to be, you can write 2h minus k plus 1 equals 0 and h minus 2k negative 1 equal to 0, right?
Yes.
And we have to solve these two equations for h and k. Okay. So how can we solve 2h minus k plus 1 equals 0 and h minus 2k minus 1 equals 0? 2h minus k plus 1. 2h minus k plus 1 equals 0 and h minus 2k minus 1. H minus 2k minus 1 equals 0. How would you solve that?
I got h equals 3 over 5 and k equals minus 1 over 5.
Are you sure?
Yeah,
Let me,
and
I think that was your mistake. So to solve these two equations, we can use the coefficient method. Like we can multiply the second equation with 2. If you would multiply this equation with 2 on both sides, right? So
yeah,
it's going to be 2h minus 4k minus 2 equals 0, and the top equation is same, 2h minus k plus 1 equals 0. If you would subtract these equations, you have to change the signs like this. Simplify, minus 4k plus k, it's going to be negative 3k. Negative 2, negative 1 is negative 3 equals 0. So negative 3k is going to be positive 3 and k is equal to negative 1. Does it make sense?
yeah,
That was your mistake. Okay, no problem. Now you can plug in k equals negative 1 into either of these equations and solve for solve for h. So it's going to be 2h minus k. K is negative 1, so it's going to be plus 1. Plus 1 equals 0. 2h plus 2 equals 0. And h is going to be negative 1, same thing, right? So h and k
yeah,
is negative 1. Erase that. H and k is negative. H is equal to negative 1, k equals to negative 1. Okay, so we are done with the second step. What was this third? So
now you
take a look at this one. Like we're gonna take 2h minus k means the constant term 0. So your equation will reduce into 2x minus y, like dy by dx equals 2x minus y over x minus 2y, right?
yeah.
2x minus y over x minus, okay, perfect. Now, what's the next step?
Now I write y equals vx and
Yes, have to take a substitution, that is capital Y equals V capital X, right? And then we have to take the derivative because we're going to introduce a new substitution, Vx. So we would have to find the derivative dy by dx, means with respect to capital X. This one, we have to find the value of dy by dx. So whenever you would, usually in differentials and in derivatives and integration, whenever we have to take the substitution, it means we would have to convert everything in terms of that substitution. So y equals vx, we have to find the derivative dy by dx by product rule. First function same, the derivative of second function, that will be 1 plus second function same, the derivative of v, that will be dv over dx, right?
yeah,
Okay, perfect. Let's plug in these values. dy by dx is v plus x dv over dx equals 2x minus y is vx over x minus 2 vx. Got it?
yeah.
Okay, we have to simplify it, and would have to make the differential equation in terms of v and x. Okay, so v plus x dv over dx equals, you can factor out x on the top, it's going to be 2 minus v over x 1 minus 2v, right? Will we cancel off?
Yes.
It's going to be v plus x dv over dx equals 2 minus v over 1 minus 2v. You got it?
Yeah.
Sounds good. Okay. Now this is our differential equation in terms of x and v. So we'd have to simplify, and then we'd have to separate the variables. So first of all, you can write x dv over dx equals 2 minus v over 1 minus 2v, and just take this v on the right side, it's going to be negative v if you subtract v on both sides. Okay, before separating the variable, we have to simplify this fraction, 2 minus v over 1 minus 2v minus v. So how can we simplify? Let's say this is 2 minus v over 1 minus 2v, negative v. You can just multiply 1 minus 2v over 1 minus 2v to make the same denominator 1 minus 2v. On the top, it will be 2 minus v minus v times 1 minus 2v, right? And after simplify the top, it will be 2 minus v and plus 2v square, right? So 2v square minus 2v, yeah, 2v square minus 2v and plus 2. Yes, it is. So we have, after simplifying, we got something like this. So we can write this differential equation, x dv over dx equals 2v square minus 2v plus 2 over 1 minus 2v. Does that make sense?
Yes.
Okay, great. Now, what's the next step? You have to separate the variable, right?
Yes.
So we got x dv over dx equals 2v square minus 2v plus 2 over 1 minus 2v. So we can just write this, the right side on the left side, and this x dx on the right side. So you would have to flip this fraction on the left side. When you would multiply both sides with 1 minus 2v, so you would get 1 minus 2v right over there, and divide top thing on both sides, you would get 2v square minus 2v plus 2 dv, right? And x over dx. So this dx will be multiplied on the right side, and this x will be divided on the right side, 1 over x dx. So we are done with the separation of variables. Right, now we have to apply integral on both sides and solve for that. Okay, so it's going to be, where is that? Yeah. Now, if you would apply integral on both sides, the right side is pretty simple, that is ln x plus c. What about the left side? 1 minus 2v or 2v square minus 2v. If you take a look at this one, 1 minus 2v over, if you factor out 2 is common, you can take it out. It's going to be v square minus v plus 1, right?
Yes.
So we can use substitution method to solve this integral, or you can use the direct method. The formula for that is, I think you've learned that whenever you have a function at the bottom and its derivative exists on the top, its integral would be ln lower function, natural log of lower function plus c. Just like the integral of 1 over x is ln x, right? Like x is the lower function, its derivative is 1 that exists on the top, so the integral will be ln x, logarithm of the lower function. Just like when you have a different function, f of x, if its derivative exists on the top, your integral will be ln f of x plus c. Does that make sense?
Yes.
So if you take a look at this function, Lower expression is v squared minus v plus 1. Its derivative would be 2v minus 1. Does that make sense? Like its derivative will be 2v minus 1. So if we have 2v minus 1 on the top, then we can just apply the formula. But there is 1 minus 2v, like a different thing, right? So how can we do that? We can just convert 1 minus 2v into 2v minus 1. How? We can just multiply and divide with a negative sign. Like you can write a negative sign outside, and then you can just write, you can just convert these signs. This negative 2v will be positive 2v, positive 1 will turn into negative 1. Now, lower function has the derivative on the top, 2v minus 1. So negative 1/2, what will be the integral of this expression? It will be natural log of v squared minus v plus 1 equals ln x plus c. Does it make sense? Or you can just write ln c.
Yeah.
Great. Now, I think the rest of the steps are pretty simple. You have to simplify it. You have to simplify it and just you have to write the values of x and y in terms of small x and small y. First, you would have to reduce v. You would have to convert v into x and y. Like your substitution was y equals vx, right?
Yeah.
So the value of v would be y over x, something like that. How can we simplify somehow? Like this is ln x plus ln c, right? How can we simplify? First of all, let's do the simplification. Let's do the simplification.
Right. ln of x plus c.
Look, ln v squared negative v plus 1. You can write this negative on half on the top by using logarithmic property.
Yeah.
Equals, you can write, let's say ln cx, right? Or xc.
Yeah.
Using the logarithmic property. Ln a plus ln b is ln a times b. Now you can apply e on both sides. So it's going to be v squared negative v plus 1 to the raised by negative 1/2 equals xc, right? Now you can just write x. Like you can just simplify this in terms of variable, like x is equal to, just divide c on both sides, 1 over c. 1 over c is just constant, so you write capital C into v squared minus v plus 1 to the raised by negative 1/2. You got it?
Yes.
Perfect. So further, if you want to simplify, like you want to remove this negative 1/2, you can just take the square on both sides or something like that to simplify it. Like this is x equals c over v squared negative v plus 1, right? To the raised by 1/2. Like this. Or you can just write this on the left side, like v squared negative v plus 1 square root. 1/2 is just square root times x equals c. If you would take square on both sides, you would get x squared and v squared minus v plus 1. It's just simplification, nothing else, equals c. Now you can just write the values of x and v, right? X and v, and you would get your final result. You got it?
Yes.
So v is equal to y over x, right? V is equal to y over x. And what is the value of y and x? Like you would have to plug in directly into this expression, v is equal to y over x. What was the value of y? So basically your capital X was, or small x was capital X plus h, right? So capital X would be x minus h, right? X minus h, but the value of h was negative 1, so it will turn into positive 1, right? We got h and k equals negative 1. If you plug in h equals negative 1 right over there, capital X would be small x plus 1, and similarly capital Y would be y plus 1. So simply this would be x h plus 1, x plus 1, and y plus 1. Capital Y would be small y plus 1, right? So small y plus 1 over small x plus 1. These are the values of y and x, right? So v, you can replace v with y plus 1 over x plus 1 right over there. Simplify, and then simplify. That's it. Got it?
Yeah.
let me write down the final result. So we have something like capital X square into V square minus V plus 1 equals C, right? Now, what is the value of capital X? That is small x plus 1 whole square. What is V? V is y plus 1 over x plus 1, y plus 1 over x plus 1 whole square, right? Minus what is V? Y plus 1 over x plus 1 equals C. And the next thing is just simplification. You can just simplify and make a compact form of the differential, the required result, right? Got it?
Yes. Yeah.
This is really important topic. Like the previous problems and topics that we did were quite simple as compared with this one. So you'd have to practice a couple of problems
Yeah.
related to this topic, right? Great.